Welcome, data people. We are Zuma. My name is Matt, and this is the Data for Good podcast. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company focusing on data positions across Berlin. The Data for Good podcast is full of data science, analytics, and engineering, giving you a platform to hear the thoughts and opinions of data leaders from Berlin and beyond. Today, we are joined by Tadej Štajner, Data Engineering Manager at SumUp. Tadej, welcome. How are you?
Thanks, Matt. Welcome. Thanks for having me here. So far, good.
It's great to have you on. So, yeah, for those who don't know, a quick introduction about yourself.
So, thanks. So I've been in the, let's say, data game for quite a bit in various roles. So initially, my kickoff in the career was doing basically a PhD in machine learning, and this type of things are in the natural language world.
Okay.
Before it was cool. So
Yep.
So that was like a decade ago. And after that, I kind of moved more into data science to be, let's say, more on the applied side. I didn't have the patience to be a proper academic, if you want to call it like that.
Yeah.
And then out of that, it turns out that being a good data scientist means that you have to learn data engineering. And in some cases, if you want to be a good data engineer, you have to learn systems, infrastructure, and so on. Basically, at some point you hit bottom, then someone has to be below you in the stack. Anyway, long story short, so I'm originally from Slovenia. I moved to Berlin 8 years ago now. I worked in various companies, like startups, bigger companies. I think the previous job before SumUp was Here Technologies, which is actually a pretty big player in automotive. But most consumers or people would know it as Nokia, the Maps division. But now, for the past 3 years, I've been at SumUp. So it's one of the bigger fintechs here in Berlin. Not only Berlin, by the way, there's like an amazing office also in Sofia, in Sao Paulo, Warsaw, London. So pretty Paris, but I'm probably forgetting some. And it's a pretty interesting place since a lot of the really key core fintech things are fundamentally data driven. So there's lots of problems to be solved there for people like myself and the people I manage. So for the past year, I've been leading a team, building what we call a data and machine learning platform for the risk and compliance use cases, where pretty much is the first place where you would encounter, data science happening in finance. And what also makes this a bit interesting is that I kind of moved from a data science towards more like building tools for other data scientists so that they can be their best selves, if you want.
Yeah, which is not a too uncommon route. We see a lot of data scientists becoming more curious about where and how the data is getting to them and make that transition. And hopefully we're going to dig into some of that wise wisdom and those experiences today, as we are here to talk about platforms and platform teams. So to start us off on a high beginner level, what do we mean when we're talking about data platforms?
Thanks for a good question. And actually, when I talk around with people, this generally has a few different meanings that people mean. But just to be kind of to set the tone for this discussion here, what I'm following here is the definition that kind of came to light in the book called Team Topologies. So it's a really interesting book around organizing how do teams basically in software companies interact with each other. So it's the authors are Matthew Skelton and Manuel Pais, if someone is looking for that. And basically maybe it's better to define a platform by what it's actually not. So in a sense that usually you have a team which they call a stream aligned team. In that case, there's a few other subtypes, but fundamentally it's basically, the team that solves business cases. And at some point, the problem domain of their kind of the stack grows. And as long as there are multiple teams and their stack is growing and growing, not every team that looks the same should be developing their infrastructure. And that is kind of the point where it makes sense to have a platform team building this infrastructure for all of them, so that they can kind of get economy of scale by having one team build something for more that they can focus on and leave the, let's say, stream aligned, or let's say the business apply team doing like what they do best, so that they don't have to like, play with servers and have fun with firewalls and so on. But the other meaning that I'm just kind of like, just to get out of the way, is often conflated here, is the platform as just another word for infrastructure or systems.
Yeah.
Which is, in 90% of cases, this is actually overlapping. So it's not completely wrong to conflate these things.
Yeah.
Because the first platform team that any company is going to grow is basically the systems team, like the people manage their servers, the Kubernetes or whatever thing they might be having to keep the lights on. But as you kind of grow and you specialize, like I think at bigger companies, you'd see platforms happening at any level. So it doesn't need to be like only like systems level. It can be some, let's say, in our case, we have a data platform, which is already, like a bit, more specialized, because there's multiple data teams, and there's even a smaller subset of like a machine learning platform, which kind of assumes there being a data platform and covers an even smaller audience. But in our case, we still have, let's say, I don't know, 8, 7, 8, 9 data science teams, where this still makes economy of scale like work.
Yeah.
So that's pretty much kind of the definition I'll be going with. And and this means a few more things. So in terms of framing it like that you're building an internal product and not only like being like a support function. So that's the second key part, is that it gives you like, it's your own identity, your own purpose, missions, that's beyond just, like a horizontal function across the company. So I think it's a really important way that like systems teams don't fall into the IT department trap, because that's not fun for anyone anymore. It basically also means that you manage it as its own product. So that's another thing, is that a platform is not only, let's say, a different way to call your systems people, it's also a way to kind of point to something. Hey, this thing actually is creating value. It is serving a business case. Yes, it's one step removed from the customer, but at some point in any complex domain, you're going to have like a whole network of this type of systems platform services that in some cases are going to be like 5 steps removed from the customers, but they still matter in some form. And being able to communicate that, well, that's where the whole language and framework of platforms is quite handy to have.
So how do platforms differ to classical DevOps and system teams?
That's another thing, which is, let's say, kind of horizontal versus, so in the sense that it's kind of what the culture evolved into. So I would say that systems teams became DevOps became platforms, but it's not completely correct, because not everything got lost here. I think we still do DevOps. We still call things DevOps.
Yeah.
But in that sense, it allows you, it's actually a really good way to practice DevOps. So in the sense that DevOps, if you look at the fundamental like definition, it's kind of having engineering and deployment like self-contained in one team. So it doesn't talk about like, servers and cables, but it's like people that build it, people run it, if you just kind of leave it there. And if you have a model of platforms where people can autonomously deploy their own things, you can have every part of the stack operate itself autonomously. So it actually, having platforms is actually a really good way to have everyone in the company practice DevOps on their own level of the stack. Whereas, let's say, compared to in this, let's say, old systems way of things, you would, let's say, send a deployment package to your IT department. They would queue it for their next deployment window, Like at our last place, a deployment was something that, you had to have an involve head of IT, and things were like, way more throw across the wall and pray to your Jira gods so something will happen. Whereas here, you're supposed to have this autonomy, which, I mean, this is nothing new here, but it kind of like, there's like a nice tailwind pulling everything together.
And further evolution, you mentioned the ML platform. So what are the nuances there that compare it to a normal or a standardized data platform?
Yeah, fair enough. I think it's also, so going from like to the beginning of like what platforms kind of start with, you have like, the usual Kubernetes platform, how to isolate abstraction of Helm charts away so that people can just like deploy some sort of apps in certain template patterns. And then at some point you say, hey, this app seems to be moving a lot of data, and they're always, the complexity is never in the app being deployed, is usually in the like databases or the data lake resources, or there's always like a storage aspect to it. So that kind of like puts this, let's say the app deployment abstraction is not enough. You need to also associate it with like your storage. So you have compute plus storage. And in terms of data, there's a lot of things that are very, very standardized already. I think you had the point, mentioned the word standardized, and this is actually pretty true. I would say 5 years ago, it was still a bit more like a wild scenario. Like, are we using Hadoop? Are we using Spark? Are we using Oracle? You know, this was kind of already, there's still discussions what are the best tools. But if someone says a data platform in 2023, there's a lot of things that you kind of assume that are there. You know, you have like a governance model, access control, like you have a compute, the distributed compute, of course. Also, usually it's also separation between compute and storage, bulk storage, database storage. There's different requirements for different use cases. And usually there's like also option to like pick and choose. You have, let's say, you want for compute maybe BigQuery or Spark, and then for storage you want like your data lake or your, I don't know, high performance computing Ceph file system, or so something that your scientists tell that they want. Kind of the pieces are like, they look kind of the same from this big picture. So that's, and this is something that if someone says that they're doing a data platform, you can pretty much guess like out of what exactly their data they look like these days.
Make assumptions. And then on top of that, what makes it an ML platform?
Yeah, okay, that's cool. So that's where the fun is. Like, I would say the data, I think, is kind of like, you know, business as usual. You can buy one, like, you know, Databricks is happy to drop one in your whatever account on whichever cloud you want, or not making advertisements for them, but they're like one of many, and they happen to be in many people's inboxes. The ML part is then say, okay, now if you say data platform, you can have like, okay, I have data for analytics. This is the usual one. Like I would say 90% or like maybe 70 or something is someone wants dashboards or someone wants reports. Then it's like, okay, maybe it's an operational one. So someone wants like some triggers being fired when some quantity goes up, you know, something happens in the business once on the result of this thing. Or let's say in my previous place, on most of the data in terms of geoinformatics, it was actually operational because it was building navigation maps. It was like massive data pipelines going and collecting geoinfo data from whatever source imaginable, and then eventually compiling into the, you know, embedded Garmin watches or the infotainment on your car, or I think also Windows Maps was one of the other outputs. So there was like many inputs, many outputs, and this is purely operational. And then the last one, I think, maybe not the last one, there's probably others, but the one that I'm kind of involved in is the ML platform. And this is where you actually have a system that makes decisions based on this data. So there's like a slight distinction with an operational system would make an action that kind of like triggers something, but usually there's like going to be a human involved on the other side, or some pretty mechanical process. Whereas with ML platforms, at least the way that we use them in fintech, you actually make business decisions on a day-to-day level, which is, let's say, fraud-related, money laundering-related stuff. So these things can have like serious impact, and it kind of, what this brings with you is that you kind of have to first have the level of trust in your data and everything that you do with it. You have to trust whatever your decision-making system is doing, which means that, and also in our case, we have lots of very strict operational constraints about performance and reliability and so on. And coupled with the fact that our data scientists love doing like super expensive queries to make decisions on. So in this, basically everything is kind of then oriented towards solving those things at once. And as you imagine, it's not a cheap thing to run or build, but it exists and does those things fairly well so far.
So what's the point when you say it's worth investing?
So in that case, yeah, that's a good one. Another one. So in the ML's platform, what you basically support is, let's say, your decision making, and then the step before decision making is someone has to train the model that makes the decisions, which means that you have to support the training part as well. So and the complexities here are on the decision making side. Usually you have to do something that can do expensive queries really fast.
Yeah.
So that's the hard part on the online side, what we call, and then the offline side, which is like the where to train the models. You have to be able to basically reconstruct the world at any point in the past. So what usually happens, at least in finance, is your training data comes way later than when the event actually happens. So for example, someone reports fraud, you got this information like months later usually, or weeks later.
Yeah.
So you have to be able to reconstruct the state of that user or merchant in our case way earlier in the past. And this also means that you have to make your database time travel capable, which is another kind of relatively expensive things to do. So these two things combined make it a bit tricky for a data science team to pull off on their own. So that's why that's one of the things where we saw that this needs to be a platform, because this is the point where the technology stack of one team that's supposed to be solving fraud problems, for example, started growing into like super advanced database stuff. So, and this kind of justified, okay, this is like two different people have to be working on this, but it doesn't have to be like that in general. So I'm kind of not trying to sell that everyone needs to have an extremely like, fast and, time travelable system, although the second really helps. But in the default scenario, let's say you have a small data science team, you're a startup of 10 people, you have 2 data scientists maybe. A lot of these things can be also done just in like a small Python script or in a notebook or something like that.
Yeah.
But you need to relax some of these constraints. You either don't have very fresh data, your model either doesn't respond in live, or your time travel is not perfect. So you have to make some compromises. But this surprisingly works quite okay in quite a lot of cases. So not everyone needs to go like the full machinery. But I think many of these fintech cases around fraud and money laundering do play out quite well. And if I look at other, let's say, ML platform use cases on conferences and so on, they are also quite similar looking to what we have. So it's not sure if that's a bad thing or good thing, but it's also converging. And I think beyond these two things, like the hard data parts, you also need to have a pretty strong observability setup. So basically seeing what your decisions are making. So not only observe the output of your system, are we blocking too many people, or are we letting too many fraudsters through or something, but also, is my data, does it look like how I expect it to look like? There's this whole dimension of data quality, of the continuous checking of it, which surprisingly, when you design a system, you think it's going to work. Of course it's going to work, but in practice, at some level of complexity, just due to pure like entropy and chaos, there's going to be always something that doesn't work. And if you have a huge chain of dependencies, that means it's at any given time, one of your processes is broken. And that's also a lot of things that you are not fun for data scientists to work on. So that's also another use case for building out this like high performance databases, the time travel data engineering world, and the whole observability things, which is more suited to either infra like engineers or data engineers as well. And it turns out that these interfaces of like, how do you have a feature store, how do you have an MLOps tooling, and these things are very much standardized now across the industry. So this is where the ML platforms live these days.
So it sounds like nearly everything can be platformized, I guess. So what sorts of platforms do you see succeeding SumUp or in the wider industry?
Yeah. All right. Yeah. Okay. So I probably have to say that I see ours succeeding. So I think that one's probably a fair game by this point, but it was maybe like a few years ago, it might not have been an obvious choice. So basically, when the person that founded this had to like, make a case that this is going to be the right thing to do, even though it's going to take, let's say, more than 3 quarters for it to actually reach production. I mean, it's supposed to reach production in 1, but then in 3 it was fair enough. And I think at this point we kind of handle enough of the use cases that we can say, okay, this thing actually does make sense. But in otherwise, I also see platforms being done in cases where there's like a at business, let's say second line business services, I would say, maybe understanding how better, I'll explain how SumUp would be structured so that this makes more sense. So SumUp always has like a markets because let's say you have Brazil, you have Latam, you have North America, Europe. Like there's all the markets that we operate in. They're broken down by various like criteria, who manages what, which banking licenses, where, and so on. And they have a lot of autonomy. So as a SumUp, as a big company, we actually have a surprising amount of like decision-making autonomy inside the tribes.
Right.
Which means that markets sometimes are gonna, if they're blocked by something, they often have some of their own engineers. They're just gonna solve something on their own, which results in like data platforms existing as someone's computer under their desk, just kind of running some random things, which often works quite a long time, but is not a very sustainable solution for any serious thing. So this is where like things happen, that often markets solve their own problems, and then someone on the more like one of the central org tribes, or like we call them global, but in our case risk and compliance, they see, hey, we see that you're setting up this on your own, and we also saw that the Brazil guys set up on their own something really similar, and we see also someone in EU wants to do the same. What if we make a platform out of this and everyone uses this? So and this I've seen happening for things like processes on like how do you onboard people, how do you make certain risk decisions, how do you define risk policies. So I won't go into too much detail, but this type of thing, which I would call like second line. So it's not immediately the first thing. In markets you often have like a strong support team, and that's very much market specific. So some things you cannot really make global, but some things one level deeper you can. And in this case, this is why fintechs often grow like globally and become competitive, like PayPal being the elephant in the room here, is that a lot of problems really kind of can be handled at a global level quite well, but you have to have a good kind of estimation, where do you cut the boundary between what do you let markets handle versus what do you solve at a global level. This boundary shifts a bit, so that's kind of like one of the high-level decisions someone doing strategy has to be making here, or it gets made for them at some point. But so in that sense, I see that if you have a global company, the boundary between market and global is going to be always like a very good case to make platforms of, and even for things that are like surprisingly high level. So in our case, we have things like platforms where the customer is not a developer, but they're like an agent, support agent, or risk policy agent that defines like what they want to achieve. And whereas in a non-platform world, they would need to like code something. Someone in a global team builds an interface for them that they can do this in like whatever is a self-service way. So this is kind of going back to the definition of a platform. It doesn't imply that it's a platform where you run code, but where you can do what you need to do in a self-service way. So that's kind of the answer here. And but maybe more in general, to be also more concrete, things like platforms that seem to might work with things like reporting, things that end up being like business functions or like horizontal functions in other domains. And the other factor that someone should look at is, so not every business function should become a platform, but cases where you otherwise see a lot of back and forth when you try to get something done. Back and forth is largely just some information exchange, like kind of routine stuff. And if someone decides to automate that, that means that if you can, let's say, if someone on like an upstream team can get stuff done without a downstream team, it means that this has been platformized in a way.
So many benefits, it appears. What are the failures? What can go wrong?
Oh yeah, okay. So there's a few ways. So
what do we need to be cautious of?
Oh yeah, every day. Okay, where to start? Let's start with the ones that I think I have on the top of my head. Basically, one is that there's a different type of, so if I go back to the team topologies definition, there's like a stream aligned team and there's a platform team, but there's also like two different types. One is like enabling team, which basically doesn't run products on their own, but they basically drop themselves as parachuters, and help someone at their project and then they leave. And then the fourth type is a complicated subsystem team, which means that there's like a very specific system that only someone can understand, and it has to be like isolated away. And a case that I've worked with that was one problem is that the team, it doesn't fit in one of these four buckets. So either you have a kind of a quasi platform team that happens to be solving direct business use cases. So it's kind of like at the same time platform plus like applied team, which like there's like some benefit of being your own user in terms of eating your own dog food, but in terms of ways of working and how your priorities interact, this thing can go really wrong. So you have to kind of firewall these things quite well. And the second one was being at the same time a platform team and the enabling team, which in practice many platform teams are, because often you need to be able to help your users use your stuff. At least from what we saw, we kicked off our platform with something that was quite technical to use. Like we used Spark as our data technology, which is basically something data engineers are like usually fine with. Data scientists all needed to learn it. And this was also one thing that made us, I would say at some point we were maybe like a 30% enabling in terms of workload, and then maybe 60% actually platform. And these things also, so the mixing itself, the problems become once you start making priorities, because it's kind of hard to prioritize both. And the mental, let's say, interruption workflow is totally different. So if you're building something, you have like a total normal engineering flow. You kind of you have your Jira board, you have your sprints, you can plan things on an ongoing basis. Whereas with enabling, you're often like, you're expected to focus on something on some users and solve their problem and then move on to something else. But these things are usually way more, let's say, short-term urgent, whereas your building work is supposed to be less urgent. But in the end, if you let your enabling work take over, then you're gonna get nothing done. And it doesn't take actually more than a third of enabling to like completely trash your concentration on your actual building work. So this is where it makes sense at some point to make a dedicated enabling team that just basically jumps at problems, puts out fires and so on. And I think actually right now I'm also in a position where we're even solving quite a lot of specific business problems. Just generally that it made sense to do so. So I don't want to go to details, but generally I would say that now we're like half of our effort are actually on business problems versus half on the platform. And as a manager, one of the things that I'm trying to like keep in context is like, okay, this is not a platform work. This is way beyond what our team was kind of designed to do. And there's like a fine line to walk, when is this sustainable, and so that you can actually like learn things that will help you build a platform. But at the same time, if you do this too much, you're not going to build anything. You're just going to be working on random projects here and there. So these are the problems where you have too much to do. The other side is when you have not enough to do, which is usually a case where your platform is basically done, and nobody is asking you for any new features. They would like to keep it running, but generally as a product, that sometimes you hit a ceiling on how much your internal market basically is willing to accept. And mainly it's because if you want to look from a product perspective, your addressable market is bound by your company size. So which means that unless you're going to get spun out, which rarely happens, but can, there's at some point you run out of customers, and that means that kind of you have to decide, okay, I have X engineers, nobody's looking for new features. This needs to kind of like change into something else. And the third thing is support. That one, I think we also had like quite a lot of back and forth, and I think with a lot of help from my team, we kind of made it sustainable. But the downside of picking, let's say, you can have a choice. You can either pick like a very low level tech where people can build stuff like with small Lego pieces and then build things on top of them. Or you can have something that's, like an Apple experience, you can do these three things with these three buttons and that's it. And there's like a spectrum in the middle. And usually the Apple option usually has less support but it's also less useful for people in the end in terms of if you didn't nail down those three things well, and it turns out people cannot use it, you're gone.
Yeah.
But the one which you pick, the small Legos, which is kind of what we generally bias to, is also means that you have to teach people to use those Legos, and that just happens to be a lot of work. So that's pretty much it. And it's also very interrupting work. And but okay, going to close this one, beyond too much. The key part here is you have to be kind of humble on how much do you understand your users. So if like initially I was a data scientist, I came in like, okay, I know what these people need, and that kind of gets you so far.
Yeah.
Like your first guesses tend to be quite good, and at some point you have to say, okay, I haven't been here yet. This is like a new forest that I'm walking through. And that's the point where you say, I have to say, okay, I have to let my users kind of do this one on their own. I'll give them the tools and they'll have to do it the hard way, because otherwise I'm going to get stuck with them somehow. So it's kind of like, if you know a lot about the domain, how it works, what the solution is going to look like, you do the Apple thing, you make like one nice shiny button. Yeah. But if you kind of like say, okay, this one, I kind of know where the dragons are, but the rest is kind of empty map. Here's your tools, here's your pickaxe, then go play Minecraft and solve something. So
slowly handing over the reins.
Yeah, pretty much.
Awesome. Well, conscious of time, so let's bring this one home. A lot of valuable insights you shared with us today. What is it like working on a platform? What experience have you had of your colleagues, your peers? How do they get motivated to work on a platform?
So motivation is very different across every person, as you've seen. Like even like when you're recruiting, you have to line up with who's motivated doing what in general. So, and as someone doing leadership, same thing applies. And so one thing that works really well here is that you can work on the hard version of the problem. So in the sense that, let's say if you're interested in, let's say, distributed computing or something like, making stuff run fast, if it means that your PC at home has RGB lights and is very noisy, this type of people, if you work on let's say a business team, you're gonna mainly solve business problems, and sometimes you're gonna have to solve some, let's say, optimization problem as part of your business problem, but it's never gonna go beyond that. But if this is something that you really like doing, you need to be going to a place where someone actually can justify solving this type of problems all the time. And this kind of like is more likely going to happen when someone's building a platform, or like maybe platform is not the only place where this can happen, but generally you're going to have to move like down the stack where someone has the economy of scale of solving some specific type of problem for everyone at once. So this is one piece of motivation, someone who wants to work on hard problems. And being able to learn from lots of different user teams. So that's the other part, is visibility. So if you're on a one data science team, you talk with your colleagues. If you're on a platform team, data ML platform team serving data scientists, you talk with 50 data scientists that are using those things, and kind of like you have lots of things to learn. If you want, it's the other thing is there's downside to this as well. So you're one step further from where the money is, or let's say where the user value gets created. So if you talk with some business person, they're gonna know exactly, like, say, okay, if you're in, I don't know, Brazil market sales team, it's very easy to show like how well things are going. When you're like in marketing team, it's like, okay, one step removed. And then it's like risk and compliance team. Okay, that's even one more step somewhere deeper there. And then it's a data platform team. So like you have to do some mental math to show like 4 steps outwards from yourself. Why is this making a difference? And I think it needs to be quite deliberate and explicit in terms of how you are representing this, how you're keeping track of this. And I've seen like a lot of cases where we actually, even though we do make a difference, if you just like eyeball things, but if individuals don't really see this, they often get demotivated. It's like, I don't know what we're doing here. Like, are we good or are we the bad guys? You know, are we useless? Or
Yeah.
Sometimes it's really hard to tell this stuff from the inside, you know.
Yeah, absolutely. Well, unfortunately, that is all we have time for today. But yeah, a lot of nuggets of information there and a lot of insights to take away. So thank you very much for your time today. And to the listeners, yeah, please like and share so we can reach as many people as possible. But it is bye from us. Thanks once again today.
Yeah, no problem. Thanks. So one more thing to add, if you want to see the other part of the story, my colleague Yev Petrov has also had an interview here with the guys, and I hope what I said does not conflict with what he said, but I think we didn't let's say coordinate to keep stories straight here.
Yeah.
So
no, I think it aligns very, very nicely. Yeah, Yev was with us earlier in the series, so yeah, do check that out. But yeah, thank you once again. It's been an absolute pleasure.
Thanks a lot, Matt.
Ciao for now.